This is formula for total number of symmetric relation, that is 2 raised to the power n into n plus 1 divided by 2. We will check it for the set having elements 2 who are 1 and 2. So let us see. First of all, we will find out A cross A, because relation is the subset of Cartesian product of A cross A. So first element will be 1 1 and 1. Second element will be 1 2. Third element will be 2 1 and then 2 2. That's all. So symmetric relations, what is the information you know in symmetric relation? You know that if AB belongs to R, then BA must be there in the R. If then, okay, this is the meaning of symmetric relation. So let us see how many possibilities are there for this. Come to the back. So symmetric relations, we will make it practically. Okay, what are the possibilities? Because this is a smaller set, we can do it. First set will be your empty set, that is phi. Okay, phi there is no problem because phi is they are always present for the symmetric relationships. Second will be your member containing 1 and 2 and 2 and 1. This is the basic symmetric relations definition source. Then third can be your 1 2 will be there, 2 1 will be there. You can have 1 1. Okay. Fourth relation will be 1 2 will be there, 2 1 will be there. You can have 2 2 as well, no problem. Extra members will make no problem to you. Fifth one is your 1 2 will be there, 2 1 will be there, and 1 1 and 2 2 both will be there. There is no problem at all. Sixth one is your only 1 1, because 1 1 when reversed 1 1 is there, so no problem. Seventh one is similarly 2 2 can be there, because when you reverse it 2 2 is there. Yes. And eighth one is your, for the same logic, 1 1 and 2 2 are there, and all these together make symmetric relations. If you will use the formula, also, 2 raised to the power 2 into 2 plus 1 divided by 2. So 2 2 cancel, 2 power 3, and this is 8. Yes or no? Formula was what? 2 raised to the power n plus 1 by 2. Clear? Now I will make you how this formula happens for the set containing n elements. Okay. So come back. If your set is containing n elements, so those will be 1, 2, 3, dash, 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 n elements if you are having. Then again, A cross A. First of all, find out 1, 1, 1, 2, 1, 3, dash, 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 1, n. Then 2, 1, 2, 2, 2, 3, dash, 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 2, n. Again, 3, 1, 3, 2, 3, 3, dash, 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 3, n. 3, n. And now I will not write all the members. I will write n1, n2, n3, dash, 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 and n. Agreed? This will be a cross A. Now you have to find out the symmetric relations. How will you do it? First of all, we will also find out the diagonal elements. Diagonal elements, I have shown you those elements which are first entry and second entry both are same, 1 1 2 2 3 3 and n type of. These are called diagonal elements. Above that, the diagonal above elements, and below are the diagonal below elements. Now you can see one thing very clearly. Whatever element is there in the above diagonal 1 2, its reverse element is there in the below position. 1 3, then 3 1. Similarly for 3 2 also. This is your 2 3, this is your 3 2. Yes or no? 3n, then there will must be n3. Agreed? Means for a symmetric relation, these type of pairs we need 1 2 and 2 1. Yes or no? 1 3 and 3 1. 3n and n3 type of pairs must be there in your set. So below the diagonals, all elements are reverse of the elements which are above the diagonal. Now your diagonal elements are, how many diagonal elements are there? Diagonal elements in case of this A cross A are in n numbers. Yes, 1 1 2 2 3 3 up to n. So n numbers. Above above diagonal elements, how many will be there? You just first of all find out remaining elements. Okay, first of for that you just find out the remaining elements. Remaining elements will be total elements in n square minus n. So above diagonal element will be what? Half of this n square minus n. And below diagonal elements, below diagonal elements will be same, n square minus n upon 2, isn't it? What is the benefit of doing this is that in case of symmetric relations, why I'm taking the half? Because the reason behind that is this, that AB and BA will be treated one entity. So how many such pairs are there? Isn't it, is this clear? There will be n square minus n upon 2 pairs are there, which makes you symmetric relationship for the pair which gives you same thing after reversing 1 2 2 1 1 3 3 1. Those many pairs are in number n square minus n upon 2, because in totality there are n square minus n members which will give you a symmetric relationship in pairs. So clear. So these many elements will take. Also there will be your 1 1 also. For 1 1 also you have 1 1. 1 1 is there, 2 2 is there, up to n is there. This is also there. So all these have two choices now. How many choices? All these n members have two choices. So what you will say? 2 into 2 into 2 means they can be there and they may not be there. It doesn't harm. Okay. So n times into the remaining pair of numbers n square minus n upon 2 will also have two choices. Okay. They may be there, they may not be there. This will be go up to n square minus n upon 2 times. Just now I have shown you in the example when containing two elements. See, 1 1 is there, so it may be there, it may not be there, it doesn't harm you. 2 2 may be there, not be there, doesn't harm you. Even 5 is there also. All these elements doesn't make any harm. So all the elements have your choice, two choices are there. So this way we will make the formula. Therefore, therefore total number of symmetric relations will be 2 raised to the power n into 2 raised to the power n square minus n by 2. When you will simplify it, 2 raised to the power n square minus n by 2 plus n. Okay, so this will give you 2 raised to the power n square minus n plus 2n divided by 2, which will give you 2 raised to the power n square plus n divided by 2, and you can write n plus 1 by 2. Why I am explaining the formula? It will not come in your examination, but if you will learn in this way, you will be able to recall the formula easily. Okay, this is the reason. Now we will test it for the set containing 3 elements. If you are having 3 elements, 1, 2 and 3. So what will be the number of symmetric relations? Now you can find out using this formula. Symmetric relations will be 2 raised to the power 3 into 3 plus 1 by 2. So you will get 2 raised to the power 3 into 4 by 2. So 2 raised to the power 3 into 6. I mean 3 to the 6. That is 2 raised to the power 6. And this you can calculate. 2 to the 4 to the 8 to the 16 to the 32 to the 64. So 64 total number of symmetric relations for set containing 3 elements. Okay. Now one more thing you have to keep in mind, that there is no formula for number of transitive relations. Okay, so you have to remember it, that there is no formula for the number of transitive relations. Okay, there is there is there is no formula for formulae for transitive relations. And for equivalence relation, for equivalence relations, we use Bell formula, which I have given you in my previous shorts. Okay, you can go through that. Thank you.